Now, how to define a custom function? Custom function, you use the operator defun. And defun takes the name of the function, just a symbol with no decoration, no quotes or anything else. It just needs the name of the symbol. Then the argument list, otherwise known as the lambda list. In this case, a single argument, which is just called number, and we assume it's going to be some type of number. Notice we don't declare a data type on here. That's just the name that we chose. We called it number. And the expression is a multiply function with number times another copy of number. So number times itself. So essentially that is a square function. It takes any number and squares the number. So let's try this on the interaction. We have it entered into a file here. So when you enter a function, a piece of code, a definition, usually you enter it into a file rather than at the top level. At the top level, we could enter here defun square and so on, and that would work. It would define a function in the GDO user package. But it's usually better to write the definition inside of a file that you can save and bring back later and edit and so on. So here's a definition of square. It's in a file. It's indented automatically. I'm going to put the cursor after the last parenthesis in this definition, right at the end, and then Control X, Control E. And that actually compiles and loads the definition that precedes the cursor, and only that definition. If I did Control C, Control K, that compiles and loads the entire buffer, which for a large buffer can be time consuming. And this one has a couple warnings. They're just warnings about things were defined at the top level before, and now they're being defined in this function. So it says failed load FASL file anyway. I'm going to say yes, load anyway, because it didn't really fail. It just gave a couple warnings. If I compile again with Control C, Control K, now it's saying compiling, and now it finished with no warnings. Compilation finished, no warnings. But it did take some time. So if you just if you're just working on the definition of one definition, put the cursor at the end of it, use Control X, Control E, and that almost instantly compiles just that single definition. Now we've defined square. Over at the top level, we can go into the package that we're working in, which is training G102, and try calling the function. So let's call square with 3. And as expected, it returns 9. Let's try square with 5. What do you expect? 25. And let's try it with a floating point number, 5.25. That still gives us an answer. So it works with any type of number. The system detects the specific type of the number at runtime. You can even give, say, 5/3 as a fraction. 25/9, and it looks like it reduces the result also. So if they square 6/3, that's basically a half, and it does reduce that for you as well. Gives you the simplest fractional notation for rational numbers. So we've seen how to define and how to call simple function in Common Lisp. We've seen what a function essentially is. And functions typically don't perform side effects if they modify something as an additional action other than just yielding a result. Then we need to know about that. Right now, the functions we're talking about do not have side effects. They do not modify things. They simply return a result.